Welcome, boys and girls. So, some of you are probably wondering what I'm doing. So I'll just give you that real quick. I am trying not to break things, first of all. We're going to work on Tin Man's problem for him. That's what we're actually up to. Tin Man's coil problem. What the heck, man, is going on with these cables? Oh, that's that one. I see. Now I have another cable in my book bag. I should go get it. It's alright, we'll just tangle this thing up here today. So, I'm gonna get all my stuff back out. Tell you what, let's put this up here for the moment. Actually, that's not a bad shot, is it? Alright, the oscilloscope is completely in shambles. It needs to be completely set back up. Hey, positive peak. Before I get started, I gotta go get a cord for the baby monitor because Mama's in the shower and I can't hear them, so I'll be right back. Alright, I'm back. So you guys are like, still number one. You guys are like this. I got the, wow, that's a great shot, huh? I got those cameras installed, yeah? So check it out, I'll show you. My camera is really low. Oh, that's better. There we go. No, not full screen. I just want to display these a little differently here. want to try and display these. Well, I'm not quite. You know what? I don't have audio. That's loud. Alright, ring some bells. We should have sound now. Send some messages. Well, I'll do this anyway. Let's see. It should be video viewer. No, that's the wrong one. Next. Now I hear you dinging. There we go. So now you can see my my on-screen cameras. I'm really not sure how to work this thing, to be completely honest with you. I think the best thing to do is do remote desktop, because then I can display just the front 4, which is what I'm trying to do. Hi, Mike. Oh, what the heck? Oh, there it's populating. Let me... This password's going to change, but I'll take it off screen anyway. Alright, so I should be able to... Yeah, there we go. But what the heck is going on with my... That back really looks good. Something's funny's going on with this. There we go. Alright, now you got a nice... Now you got a nice view of the house. Now you can go. Now you can see when I go pee in the back. Anyway, let's get back to work. Okay. I'm gonna unplug the scope and get everything set back up. Turn the lights off because I want the door open because it's hot in here. But if I turn the lights on, all the bugs come in. That first camera on that first channel really looks bad. I don't know what the deal is. Yes, now you can watch for Bigfoots. Alright, it is a giant mess, so let's unmess this before I get started here. I probably don't need these giant high-end scope probes, but I need the current ones. Just don't know if I need the other ones. Alright. This guy on. I think I'm going to use the amplifier. Oh wow, the scope was on the whole time. I must have left it on and it turned the screen off. It's been on for like 3 or 4 days. Alright, unwind me. First of all, let's turn these on. Oh, there's my door shut again, the wind blowing it. Just barely off. There, that's stable there. How's my audio? Speaking pretty quietly. Gotta get all these scopes set up. So much setup to do real quick. But our test should be fairly straightforward. Alright, there's our green one. Here's the second shot. Blue one. Get you guys a better shot in a little while. That'll be in the front. You can still see me in the front. You be in the front? You make sure your neighbors know you're there, huh? Alright. This will be an interesting test. I'm doing this for Mr. Tin Man. So if you're watching, Tin Man, you're welcome. Just for you, man. This is just for you. I do need to go get my camera though. I could use my phone, I guess. But rather not. Alright, I went and got this cord in. I forgot to plug the monitor in. I'm gonna plug this in. Can't plug it in there. There we go. And now you can see people walking down the street and what's going on out there. Your neighbors are there. Neighbors? That's a weird way to spell neighbors there, Mike. Okay, let's put this camera back in its home where it used to sit. No, not sit. I said sit. Okay. Scope in place. What is that terrible reflection? Is it really that monitor over there? Wow, okay. Oh, that's fine, I guess. Okay. Alright, let's put this up here. Okay, so this is pretty well sorted. However, I need to set up all these channels. So DC coupling, these probes are times 100, I think. They are times 100. Okay, voltage inverted is off. This one should be the same. Alright, now these are current. Scale is times 10. So it's 10 millivolts per amp. It says 100. This was always confusing the last time. Right, 10 millivolts per amp. 100 amps per volt. Actually, it probably should be on times 100. 10 amps per volt. I think. He's kind of confused. But we'll set up a quick test and find out what's going on. Tell you what, I haven't done is actually figured out if I could test straight DC with these. $10 amps per volt, and the other one is 100 amps per volt, so it has to be that one. Okay, our scope is configured properly. Okay, let's go ahead and set up our power analysis. Channel 1 and 2, channel 3 and 4. Alright, so let's just see. Can I even detect? I don't. It just smells funny in here. I don't think I can detect such a small signal here. I need to pull up 10 minutes of video even though I just got done watching it. Comes a car. Oh, no, that's just the wind. It's very windy today. I have to configure all this camera stuff still, but it's pretty cool. I put a new hard drive in to test that out. I blew one up. Apparently it stopped working for some reason. I don't know, it's an old drive, but I put a new one in to see if it would blow up. And the date is wrong. Why is the date wrong? Oh, I'll fix it later. Oh yeah, stuff's over here. Alright, so let's put the chat over here in the corner. The reason I want to pull up Tin Man's video is because I wanted to look at the settings. I think it's 5 volt RMS. But what I'm going to do is I'm going to use my amplifier because it has a bunch of safeties built into it, and because I'm going to need more power, I'm going to have to pump a little bit more current in there to use my current probes properly, I think. Man, the internet is slow. How's the stream? Is it okay? It's not cutting out, right? Oh, it's cutting out. Alright, well let me disconnect this. That's probably killing us. Alright. My fault. Killing the stream with that. Because that uses a lot of bandwidth. Once I get the connection different, it won't be so bad. But I'm actually going to go this one because this has a little bit better shot in it.
Okay, running through our setup here.
This might also try to kill the feed, but bear with me. I need to move that camera down for you as well, but I'll do that in a minute. Just remind me. Wow, is it killing the stream? Oh, jeez. Okay. All right. Dang it. Apparently my internet is being very unhappy right now. I'm gonna downscale and restart. Okay. So at the moment, to zero the current probes before we get started. Okay. I'd say that's pretty happy. Maybe this one a little bit more. Alright, zero the current probes. Still have a few drop frames, but that's just what it is. Looks like we're picking up a little noise. A little AC or something. Okay. So here's what I want to do. It's 10 volts, 100 millivolts per amp. Times 10. Something tells me I need to be on the times 10. I mean, what's the other one? Times 100? No. Okay. Let's go with this one. This was really confusing the first time I set it up as well. So here's what I'm going to do. I'm going to run this through my amp because I don't trust that thing. So we're going to run that through our amp. Amp output is actually here. It is a BNC adapter. I think I installed that puppy. Yeah, water cells. Okay, and then I can put this guy on here. Alright. So turn the volume all the way down. I'll put the gain at 50. Frequency at 50, everything else can be. Should I put the gain down too? Okay. So this goes to 20 megahertz. I'm going to go ahead and put 1 megahertz. Wow. You know what? Now that I think about it, I don't know if I can use this amplifier at that high of a frequency. Yeah, I probably can't. Alright, so scrap the amplifier idea. But therein lies a problem. Let me look at something. microphone, maybe it won't kill the bandwidth. Okay, this is what I wanted to see. So he's got he's connected to channel. No, I can't read that. I need to find a better shot. Channel 1. Well, it does not work that way. Okay. Oh, I see. This is channel A and B, not 1 and 2. So channel A, he's pumping out 20 volts peak to peak. %, duty cycle. Looks like 0 offset. I'll just stick with 1 megahertz. You know, I might use my driver circuit there. I'm sure I don't want to blow this thing up. But that's not AC. Because it's not real good to run this directly, but I can't run into those high frequencies. However, guess I'll do it anyway. That's 200 and whatever the coil is ohms. That's not a very good choice. So let's go ahead and use the same coil that he was using, which is this type. Oh, Mama got up. I see you. I have a couple different coils to play with here. Actually, I have many different coils to play with. That one's probably the closest to what he was using for now. Potato chips, huh? Oh, thanks for the link. I can't play it on here. Look, I really don't want to connect this directly. And I'm almost certain that amplifier is not going to handle those frequencies. So, what I'm telling you is this might not be as easy as I thought it was going to be. Doable, but not as easy as I was thinking. Alright, pink and green, yellow and blue. We're talking millivolts, and this is 100 millivolts per amp. We should be able to measure that though. Man, that's just a bad idea. He's driving it directly from the oscilloscope, or from the signal generator, because it should be matched for the load there. Are we sure he's not connected to an amplifier? He's not though, he's just directly connected, huh? Doesn't really show that. However, I think that it is. Because he's got, well, crap. What do I do? I need a potato chip. You shouldn't be eating potato chips, Mike. See, I think I'm going to use channel 2 because oh, can't go that high. Oh, wait. Yeah, I can. Okay. I see. Well, let's just try something here. So the inside one is the inside one. That's this guy. Why did I have these zip tied? I don't know. We'll have unzip tied in there in a second. I don't know where my snips are. It'll work though. I was trying to print earlier and having freaking jammed it. I got it too hot and jammed it. I thought it needed more heat, and it actually needed less heat, and I jammed it. Stupid. Alright, we need, first of all, 100 ohms resistor. 100 ohms. Those are power resistors. Perfect. They are. They don't tell me the rating, but that's fine. Well, a chance blowing this thing up, I guess. I think I'm gonna solder these to the wire. I don't have to worry about alligator clips. You guys want a close-up shot of the bench or not? Yay or nay? I think it's better to have a close-up shot of the scope. So let's get the colors configured here. Alright, close-up shot of the bench. little bit. Let's get that shot of the share. Alright, there's your bench shot. Just for you, single lonely man. I think I'm gonna actually put you up here and then see the scope. How's that? Okay. Solder iron hot yet? Put some solder on these wires. Positive peak. I don't remember. Are you married? You got kids? Any of those things? Alright, so this is our input. And then we tie these two together. Single, no kids. You had a lot of girlfriends in your life? Yeah, lots of girlfriends. You still got girlfriends now at your age? Actually, that would be a different type of lifestyle, I will be honest. I've seen other people similar to that, similar to your style. So it's actually kind of interesting, really. Alright, so I wrote this down. Where did I put the paper? Oh, crap. Specifically wrote all this stuff down. Oh, come on. What did I do with that stuff? Maybe I didn't bring it out here with me. Obviously, it's not right in front of my face. Well, I wasted a lot of time, so therefore I need to go get it. I'll be right back. I'm back. Alright. Now maybe some unknown kids. One girlfriend had a miscarriage. Kind of sad, but things happen, I guess. Yep, that's for sure. Wild man, you. So here's my notes. Pause the video, check the notes. No, if you're watching live, you can't pause the video, but he's got negative. Okay, he's got the positive lead going out. I hope this doesn't mess up my scope, because I can't fix it. I mean my signal generator. Alright, so we're going to put channel 1. Alright, we're going to just measure across the resistor. Just like this. Channel 2. I'm going to measure also across the resistor. This is... wait, did I do that wrong? I did this wrong. Time out. I've got the resistor messed up. It's supposed to be on this lead. Don't want to screw that up now, do I? Now we gotta wait for the soldering iron to kick back on. I'll turn it off. In the meantime, I'll go take a pee. I'm gonna go leave one. I actually love the low lighting in here and the door open. Oh, it feels nice. I should have thought of that a long time ago. Well, I guess a long time ago I didn't have the low lighting at all in here, so I couldn't do this. Boo-hoo, I'm just lonely looking. Hey man, are you living the dream? That's what matters. You can't be too lonely. You got some girlfriends to call up. Surely you got some. Maybe her name is Shirley. Alright, so I think I've got that right now. I had the... I mean, it shouldn't have mattered, but... well, actually, yeah, it would have mattered. Alright, so this is the way our friend Tin Man's got it wired. We got... this wire's on the outside, okay? And this wire's on the outside. So we got in, going around, coming out, back in the same direction, going out. Alright, this is correct now. So we got our... now let's put our scope on here. So our scope ground should technically be here if we want to be in phase. Alright. Now, he was measuring voltage across resistors. What I want to measure is the current as well. So we're going to measure current going in. So blue. Alright, let's put it this way. Positive to negative. Wait. Positive to negative that way. Okay, we actually need to have it this way. Still zeroed. I'm just going to have to set it like this. I don't think it's going to hurt anything. Now we're going to measure same thing here. Okay, put this wire up here. Get it to stand up nicely. Get all these wires out of my way. Alright, fair enough. Okay. Okay. Not okay. Soon to be okay. Bear with me. Technical difficulties. Okay. I don't like the way this one's sitting though. Yeah, okay, I should 3D print some stands for these bad boys so they sit like this, huh? Yeah. Just stay put, you children. It's like getting my kids to sit on the couch during the evening. And they're all being bad. Well, not bad, but loud, annoying, and rough. Really? Come on. There. Okay. So, yellow is voltage. Purple is voltage. Let's go ahead and pull these two together. Why is it showing an arrow up? Shouldn't show that, but okay. Voltage and current. Why is the math on? How do I turn the math off? Go off. There you go. Where you at? Terrible, loud, annoying, rough. Yes, that is the description of my children. Not always, but occasionally, pretty bad. Okay, so here's what I'm going to do. I'm just going to turn this on. Hope that my scope doesn't blow up. I've got 200 ohms. Oh, it's 50 ohms impedance and I've got 100 ohms on it. I'll be fine. We are on. Alright, I'm going to go ahead and just auto set this just to see what happens. I'm only seeing voltage across. What? No. Get out of here. I might have to put that to 20 volts peak to peak. I'm pretty sure I probably will. Okay, I have to do channel 1 in order to do that. I really think that I'm not going to be able to measure this low of current. No, stop auto setting. Run, okay. What did I do? Is that freaking 60? What the heck, man? No, it's definitely from the scope. It said 1 megahertz. But there's no way. Let me measure. Alright, let's put this on. Frequency. Oh yeah, it is. It's right there. Oh, that's kilohertz. I'm only at 5. What the heck, man? Whoa. Oh, it actually was right. Okay. Now these probes say they'll measure up to 100 kilohertz. So yeah, I'm gonna have to run this through the amplifier. These particular probes don't do a good job, but what I can do, let's turn off current probes for a minute. Let's just look at the voltage. Let's see if it's in phase, shall we? Matter of fact, let's switch this to channel 1 and put it on 20 volts peak to peak. We're not getting enough power. First of all, I think I can go up to 20. Maximum output. Now we can measure some stuff. Why is this scope updating so slow? Oh, look at that phase shift. Now let's see if we can measure something with current. Oh, jeez, it's a mess, but I'm seeing a tiny little bit. See it there? Let's turn on this one and just see if it's out of phase. Alright, up. I don't understand why this thing is scanning so slow. Shouldn't be that far out, but okay. Alright, so actually the current is kind of in phase. I'm messing with the wrong knob. You know what, I'm going to dub the voltage right on top of itself so we can see that nice phase shift. And then I'm going to do the same thing to the current. I really don't know why this thing's kind of gone silly. But just for fun, let's see if we can read anything off this. It's probably all sorts of screwed up. Yeah, all the question marks mean things are screwed. Let's see, 3 and 4 are in the middle of the coil. back and measure. Channel 1, let's measure the cycle RMS. Alright, that's about the exact same that he had. Alright, this is going to be pink one, which is 3, and we're going to also measure RMS. Okay, and then channel, this is going to be 2, which is current. Actually, let's just yeah, it's not a good idea, but temporarily, let's just look at it. So, alright. Now we are not seeing a voltage difference at all. Go up in frequency. Oh yeah, we can't trust the current probes at high frequency though. Well, this is actually more of a challenge. We need to set the trigger first of all. Wow, it is just a mess no matter what I do. What is going on with this? This is, I don't know what's going on right now, but things just look completely screwed up. And there's not really any good reason for it. It's almost as if the refresh rate is just screwed up. There we go. I was way far out. I was actually seeing some screwed up nonsense. Okay. Measure. Huh. Look at that. The input is 300 something ish millivolt, and the output is 1.2, which technically, since we're measuring across the resistor, that is the voltage. So like here we might be into a here it's the opposite, but we get lower frequency, we can actually get better results. Oh, and then we go too low and we get reverse results. What I'd like to do is be able to match or at least get in the range of voltages that he was sitting at. He was sitting at about 1.25 volt input. However, I mean, it's rather interesting because the output kind of really always stays the same for the most part. But like right here, look, I can get a very low drop across that input resistor. I think Tin Man said coil does not need to be in resonance. No, that is correct. And I'm scanning a huge range of frequencies. You can see the frequency right here. Right there. See it down there in the bottom? So look at my frequency input. I mean, I'm scanning a huge, huge difference here. Now my coil is going to show this phenomenon at a different frequency than his, and it does. But it shows the best somewhere around here, right? So I need to pump more, and we got to make sure we stay below 100 kilohertz to measure with DC, or with these, not the AC stuff, but the other probes. What I could do, I'm not gonna be able to 100 kilohertz. I gotta stay below 100 kilohertz. To measure with the DC probes, or with these amp meter probes. So what that means is that I need to see this phenomenon below this frequency. Let's see if I can find anything interesting down in this range. Not really. It's all about even. I don't really see any change. In voltage potential until I get, okay, here's 100 kilohertz. You can see it on my screen there. What I'm looking for is the voltage RMS to go down on channel 1 and up on channel 3, because that's where the phenomenon is. Unfortunately, my amplifier and my current probes cannot measure this high. So just pay attention to my kilohertz input and channel 1, channel 3 RMS. Can you read the channel 3 okay? It's a bit funny maybe, that purple is hard to see. But it's not up until he was at 6.6 something up to 9.9 something kilohertz, and I'm in that range. I'm not seeing anything. But what I can do is measure the voltages across the entire circuit all at the same time, whereas he's just using one scope probe, so it's a bit difficult to do. That sucks. I can't use those probes won't go that high. I guess I'm gonna have to invest in some higher frequency current probes. There, see, now we're starting to get, now we're starting to get the drop off here. We're right around 800 something. So this is the same range. Let's keep going. And I'm going to keep going until I reach 1 point. Whoa. That just dropped off to the... I want to keep going until I get around 1 point... What did he have? 1.24 volts across the input. So I'm passing the 900. I'm getting into 1 megahertz here. I just passed 1 megahertz. Had to slow down my speed to keep from buffering so I cannot see much detail. Oh yeah. My end is still healthy, so your end is screwed. So I'm taking this pretty slow. Let's jump up by 20s here. Alright, so let's bump this up so we can get a better reading. Now the important thing here is we can still calculate the phase shift, okay? And that is important. Phase shift is what is really important in this test today. Because if you have a phase shift, then you have power transfer of different. You cannot measure this the way he was measuring it with Ohm's law, which he said that. So look at this. Look at this, okay? This is perfect evidence. You can see that even though the voltage RMS on the input is lower and the output is higher, you can absolutely see there's a full phase shift. And that phase shift is the key to understanding this experiment. Look how far out that phase is. Oh my gosh, that is so far out of phase. Look at that. This is why the phenomenon works. This is why Ohm's law cannot be used to measure. Look at that. 180. I mean, I'm almost 180 out. Look at that. Let's go back down. Because 90 degrees out, I should have the maximum differential between input and output, okay? And you can see that phase, okay, there it goes. Alright, it's going below 400 millivolts. It's going below 300, well, 400. Let me bump it up here. Alright, look at that. 350, 314, and look, now we're at like a 90 degree phase shift, okay? And then as we go back up, now it's going back up, starting to get in phase. And we're consuming more. So let's go ahead and set this at the lowest potential. About right there. See? This is making perfect sense right now. So, it's too bad my current probes won't go that high. They're just a mess. They look like nothing. It's pretty though, and I'll give you that. That's pretty cool dance music, whatever they call it, I forgot now. Okay, so I'm gonna make a very short little video with my phone. But before I do that, how can I measure phase difference? So let's go to application, let's go to phase analysis, channel 1 to channel 2, channel 1 to channel 3. Okay, oh, I don't want this to be on the screen. How did I get to that? Oh well, let's get this at this is what I wanted on screen, but I want let's go back to this. Let's just get this off the screen, even though it's lit. I'll get this off the screen, and then we'll go back to application. Now we're going to see what we're looking at here. Look at that phase shift, man. Whoa. Look at that. We're all the way up to 180. I mean, it's completely out. So we're going to go fast to show this result. Boom, 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 boom. And here's our phase shift. Right there. Boom, 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 boom. And now we're almost perfectly in phase. Look at that. Okay, well there's the results. It's too bad the current probes won't work. So, I'm going to make a video. I'm going to be very generic with this video. And I'm not going to make any claims or statements. I'm just going to prove what I'm looking at here. So what do we want to set up? First of all, let's go back to measure. Alright, let's go ahead and change, oh yeah, peak to peak. No, let's go ahead and change this to channel 1, peak to peak. And then we're going to change this to channel 3, peak to peak. And we're going to, let's put frequency on channel 1. Okay. Now we've got everything we need on screen. Savage! Okay, alright. I think I can. I haven't used this phone. I don't know. There we go. Pause it. Okay. Alright. What do I want to say? I have to do all this one-handed. Looks like I can sweep the frequencies really nicely though. And if we go back up past the high frequencies, we start seeing the same output voltage again. I just want to show the phase shift. That is all I want to do in this video. So that's all I'm going to do. I'm going to be very generic. I'm not going to do anything naughty. Okay. Here I go. See what happens. Oh, that's a picture. Hey, what's up everybody? My name's Russ with RWGresearch.com. So you're in the shed where the rodent coil research takes place. If you haven't seen that, some very interesting results there. So this is a video response actually to Tin Man Power. Hi Brad, haven't spoken to you in a long time. I don't know if you can see me on this. Glad to see you back in action. Saw you move and all that fun stuff. So you've been playing with the Tesla pancake coil. I actually have many versions of this coil here, so we can play around with all kinds. But what I want to show today is basically the results that you were seeing. Now I'm lucky enough to have, I should say I'm blessed enough to have the proper oscilloscope. Alright, this is a Tektronix TPS 2024B, and I do have the power analysis software on here. Now unfortunately, I do have the current probes, but unfortunately these things only do, let's see if we can get this to focus. I don't know how to use this thing. They only go up to, well, it's the other way. They only go up to, there you can read it. They only go up to 100 kilohertz. So these probes are actually completely useless. I want to focus, there we go. These things are actually completely useless. I'm using my phone, so I'm sorry about this poor quality. These probes are completely useless. So let's go ahead and run through this really fast. I'm not going to use the probes. I've got 100 ohm resistors, just like you did. I've got my signal generator here. Alright, it is set to 20 volts peak to peak. Currently frequency is here. 0 phase shift, 0 offset. Alright. So the oscilloscope, let me show you what you're looking at. You're looking at channel 1 is the input, channel 3 is the center resistor, and then channel 1 peak to peak, channel 3, and then I've got the frequency here. Even though it's down here, you can look at it. So what I want to show you is that I want to teach you and teach other people, which I think you know this, but you cannot measure AC with Ohm's law. You have to use watts, and you have to use power factor, and you have to understand phase shift, and it's not that complicated once you study it. However, it'll really throw you off. You guys remember the rodent coil research. You remember the meters would lie to me, but the oscilloscope would not, and that is important. So what I want to show you right now is just, I'm going to change the frequency. Alright, very simple test. I'm going to change the frequency, and I want you to watch what happens to the phase shift. I want you to watch what happens to the voltages here. So the input voltage is going to go down, and the output voltage is going to stay high. Now that's technically a current measurement. Both of them are 100 ohm resistors, 1 watt. So here we go, we're at 556. You can see the frequency here and there. So let's go ahead and do this. Oh yeah, okay, I'm going really fast in big increments here. So just pay attention to what happens. Now look at our input, RMS. Okay, I'll zoom in on this stuff later. But look at that, we're at just over 300 millivolts input and 1.29 volts RMS output. So there's your current amplification. Now what's important, and I'll zoom in on the trace here, is that phase shift. Alright, so I'm going to zoom back out because I want to show you, actually I'll zoom back in a little bit, time scale. So now I'm going to keep going, and look what happens. We actually get to a point where our phase shift is completely out of phase, 180 actually, almost, not quite. And now our input goes back up, alright, sorry about the shakiness, to, oh, looks like the stream died. Anyway, I am doing this live, by the way. So you can see the RMS voltage on channel 1 and channel 2. I'm actually pumping more voltage in. Now, like I said, I'm lucky enough to have some really nice tools here. So what I'm going to do is I'm going to go back down. Let's do it fast. Okay. Alright. So here's what I want to show you. Alright, anytime there's a question mark, it means it's measurement error. Don't read anything with a question mark. Now, channel 1, channel 2, and channel 2, channel 3 are the current probes, but I currently have those disabled just because we want to pay attention to channel 1 and channel 3 phase. Okay? So I'm starting at 666 kilohertz. Just lucky number for you. Yeah, blah, blah, blah. Anyway, I just landed on it. Give me a break. Okay. Now look at the phase shift. I'm going pretty fast here. Alright, we were at 6, now we're at 11, 13, 20, 27, 45. Let me zoom in for you so you can see that phase shifting. And there's a question mark because I'm too far in. Let me go back out. Anytime there's a question mark, you don't want to pay attention to that measurement. So you have to just set the scope up to get the measurement. Okay. So now we're going in. Alright, now we're too high on channel 1. Too far zoomed out. There's probably an auto set for this thing. Alright, so we're actually, there it is, flipped to the right phasing. So it's confused because we're getting close to 180, so it's going from positive to negative. So I'm going to go back. Alright, again I'm going kind of slow so you can see the phase shift. Alright, I need to just let it settle. Alright, there we go. And we're heading back towards the phase. Okay, so now you understand the phase shift and what happens to the current and voltage. I'm not going to go into detail here. Let's go back to measure. Alright, let's put this back so we can read. Alright, so again, let's go find our sweet spot, okay? Let's go find that sweet spot. It's where we get about 300 millivolts input versus our output. And let's get that okay, about right there is the best we can get. So this is the best we can get. Now, from what I understand, we should see somewhere around 90 degrees for the best result in this strange manner that we see here. So let's go over to the application, waveform analysis. What did I do? Waveform, no, sorry. Phase angles. And let's see where we're at. We should be right around, okay, we're at 70. 3. 60. We're actually a little low. Let's go a little bit more towards 90. Yeah, it's about 90 there, huh? So now we're over. Let's go back down. Okay, it's somewhere around here. It doesn't have a question mark, so it's a good measurement, but it's jumping around because I'm zoomed in so close. It sure is having a hard time steadying on that phase shift. But anyway, the point is here is that what you're seeing, okay, is a phase shift, and you cannot measure this type of coil with this type of measurement. So yeah, that's all I wanted to share with you. For those of you who have no idea what the heck you're looking at, please check the links in the description and go look at some of the past rodent coil research. Those are all 3D printed for you 3D printing guys. Pretty sweet. Now I'm pretty sure we can get the exact same results of these Tesla pancake coils as we did with this, with the rodent coils and with these other. I have lots of different coils to test, but I don't think I need to. I think this brought you to the point. RWGresearch live, links in the description. Peace and love. Thanks for watching. Let me know what you think in the comments. See ya. Alright, what do you guys think? Was that a terrible video? It's 11:30. It's time for me to hit the hay. Gonna do the LED test. Nah. Voltage. Tells the story. And if people are interested, I'll make a video with the resistor or with the LED, and I'll go through the change and I'll show this phase shift. Alright, I'm gonna go upload this video. Boom, like right now, because it's on my phone. I'm done for the night. Thanks for hanging out. Sorry I'm not gonna stay up stupid late. It's my birthday tomorrow. Happy birthday to me. I don't really care, but I'm going to be taking apart the garbage disposal and cleaning it out. It's full of junk and trash and stuff that won't go down. So I've got a fun-filled day of... I shouldn't curse, but I got a fun-filled day of crap. Yeah. I'll see you guys another day. Thanks for hanging out. I think we learned something today. Peace!